Okay, this video is going to go through the idea of how AAS can be used to monitor heavy metal pollution such as lead pollution, but also study trace elements. And it relates to 3 dot points in the syllabus. The first one about explaining the evidence for the need to monitor levels of one of the above ions, in our case lead, used in society, is to describe the use of atomic absorption spectroscopy and assess its impact on scientific understanding of the effect of trace elements, and also to interpret secondary data from AAS measurements and to evaluate its effectiveness in pollution control. So in your notes, in your focus area 3 notes, if you look on page 7 of your notes, it's got AAS and lead. And as we go through this lead PowerPoint, you may wish to write down some notes under the headings. There's problems caused by lead, how does lead get into the body, source of lead in the environment, how to test for lead. At the bottom of page 7, it's got a heading that should be on page 8 as an example of a case study of lead in the body and the environment. And so as we go for this lead set of notes, you can copy down information there that will help you understand how AAS can be used to detect lead and also the problems of lead. Following that on page 8 is a subheading called AAS and trace elements. There's 2 sections of notes you've got to copy in. What is a trace element and how AAS has helped the study of trace elements. So as we go through this video, you should be copying down some notes to help you understand this topic. So first of all, lead. Lead is a poison. It's got no known biological function, and there's no proven safe lower limit for lead. There's no safe amount of lead to have in your body. Lead ions, particularly lead 2+, competes with calcium and iron in your body, and therefore it can affect your bones and your blood. But it's cheap, useful, easy to mine, and therefore was used in many applications, especially paint and petrol, and thus it's pretty much everywhere. Because it's been emitted into the atmosphere in petrol, that means most places on Earth now have lead pollution of some level or another, and because old houses were painted with lead paint, that means most building debris, houses, particularly old houses, soils where things were thrown away, are contaminated with lead as well, and that means all dust, because lead petrol is also contaminated with lead. So lead is a serious problem for the world, and particularly in places where there's still a lot of lead being used. Sources of lead: up until the 1970s, paint had lead inside it, and it's not sold anymore, but that still means that old houses and soil often have a lot of lead inside them. Petrol, they used tetraethyl lead to increase engine efficiency up until they introduced unleaded petrol, but that put a whole lot of lead into the atmosphere, and therefore in dust it settled on the earth again as dust. Some occupations, such as if you work in a lead mine or a lead smelter, obviously that you'll be involved with lead, or if you work with batteries such as car batteries, you'll be involved with lead. And solder as well. A lot of solder used in circuit boards and computer electronics contains lead, because a lead tin alloy called solder has a low melting point and is a good conductor, therefore can be melted and used to join wires. Some pesticides contain it, and also cigarettes contain it as well. So there's a whole lot of sources of lead that people might encounter. When lead gets in your body, most of it goes into your long bones. We said it competed with calcium and therefore replaces some of the calcium in the calcium phosphate in your bones. So 95% of the lead in your body will end up in your bones, 4% end up in soft tissues, particularly the brain, liver and kidneys, which is where it causes a lot of problems, and about 1% in the blood. And also, if you are pregnant, it can cross quite easily through the placenta into the fetus, which has some serious impacts on the growing baby. So the ways you can absorb it: you can absorb it by breathing in the dust, you can ingest it. If you take it into your mouth, you can ingest it via your digestive system. It can be absorbed by the fetus through the mother, but also some can be absorbed through the skin in certain situations. And there's just an example again of some of the risk factors, so where you might encounter lead: mining, painting, and some of the factors that mean you absorb more lead. People whose bodies are trying to absorb more calcium, for example, such as if you've got a poor diet lacking in iron and calcium, the lead is more likely to be absorbed by your body. If you're pregnant or breastfeeding, where you need those extra nutrients, lead will be preferentially absorbed. But if you also live near a lead industry or renovating an old house, you're more likely to get lead poisoning. But particularly young children, they often put things in their mouth. It's called pica, and when they put things in their mouths, particularly if they're like toys covered in lead paint, or they pick up paint chips off the floor, they're likely to put it in their mouths. There's a case a few years ago where saw some toys recalled. I think it was some Cars branded toys from the Disney movie, Pixar movie Cars, had some toys that were painted in the factory that had used lead paint, and also some Thomas the Tank Engine trains a few years ago were painted with lead paint. They were recalled from the market because of the danger of kids putting them in their mouths. So where are people most likely to get their lead from? Most of it comes from the dust and soil, because as we said before, you have leaded paint things being disposed, which ends up in the soil, but also leaded petrol put a lot of lead in the atmosphere, which is then settled in dust and also into the soil as well. There's 20% comes from food contamination, 15% from the air, and 10% from water and other sources. That's the usual contributions of lead poisoning in people. The effects of lead are quite dramatic, and it's related to their concentration. The effects of lead do depend on the concentration of lead in your body, and the IQ effects are particularly related to the total dosage in childhood. But this graph here has lead concentrations in micrograms per deciliter. To convert that to parts per million, you've got to divide by 100. So look at the top of the scale. Death occurs at 150 micrograms per deciliter, which means that death actually occurs at 1.5 parts per million. So in very, very low concentrations, lead is a fatal and deadly poison. And as we go up from the bottom, at 10 micrograms per deciliter, or just 0.1 parts per million, that's where there is measurable IQ and IQ loss. As we get higher and higher, you get reduced ability to make blood cells, premature birth weight, less ability to use vitamin D. At 0.2 parts per million, that's when your nerves start to become affected. At 0.3 parts per million, it affects your blood pressure and your hearing. At 0.4 parts per million, you get greater nerve problems. You can become infertile. Kidney damage begins. At 0.5 parts per million, once again, your blood is further affected. At about 1 part per million, that's when you start having some serious neurological damage. You get kidney damage, coma and seizures, and anemia as well. So even in very low concentrations, up to 0.1 to 1 part per million, it's very dangerous, and at 1.5 parts per million, it becomes deadly. And there's been a lot of studies done on the effect of lead on people's brain development, and they've done a study that suggests that each 0.1 part per million in children lowers the IQ by 4 to 7 points. And the Australian studies showed the same thing, but they showed each 0.1 part per million of lead lowers IQ by 3 to 5 IQ points. And they've done a lot of studies on the effect of lead on behaviour, and delinquency rates are 8 times higher in the top 30% of people with the highest bone lead. And there's been measurable adverse behaviour changes in 2-year-olds depending on their lead concentrations. They've done some studies related to that second last point of people in prisons in America, and people in prisons have a much higher likelihood to have higher lead concentrations in their body, suggesting that lead is possibly a cause for their behaviour, because it does affect your brain, it does affect your neurons, and therefore it could affect your behaviour as far as these studies are concerned. There's been interesting studies done in the last couple of years on what's happened in the world, or particularly in America, as first of all lead concentrations increase as we use tetraethyl lead, and then decrease as we started using unleaded petrol. And these graphs seem to have a nice correlation. It shows that the blue is the lead in the atmosphere versus the brown is the thing they're studying. And they're looking at violent crimes, the rate of violent crime from 1960 to 2009. And it's an interesting match. They can see that as the lead in the atmosphere increased, so did violent crime. There's quite a nice correlation there between lead in the atmosphere and violent crime. But also for pregnancies in 15 to 17-year-olds, so it's linking to bad decision making possibly, and also risky behaviours. And one thing to be aware of is that just because there's a correlation, just because these two graphs look the same, doesn't mean that one causes the other. It doesn't actually mean that lead caused these problems, but seems to be a link there seems to be correlation there, so it's something for further study. So whenever you look at a graph in any source, any resource you get, secondary source, just because there's a trend or there's a common trend doesn't mean that one causes the other, but the scientists who put these together are suggesting that there is a correlation because they've done some further statistical analysis which suggests that lead is very closely linked to violent crime and poor decision making and risky behaviours. So how do you test? Well, AAS is often used for lead testing, and mainly because very low concentrations are dangerous, which is too low for reliable precipitation analysis. So because lead is so dangerous in such low concentrations, we need a technique that can record low concentrations, and that technique is AAS. AAS is very fast and accurate when you're testing for one metal. In this case, if you're just testing for lead, AAS is very, very fast and accurate, and can be used to test a range of samples: blood, soil, air, and water. So AAS is very useful for testing lead. The main one being, though, because it can test very low concentrations where lead is actually quite dangerous. Okay, so how do you test for lead? Well, if you're testing lead in the air, what you can do is place air filters around major industries, roads and cities, where you want to see how much lead's in the air. You can also take soil samples at various distances, and they've done this test in Adelaide and Western Australia, where they've taken soil samples at various distances from cities, and they've taken soil samples at various distances from major highways to see how the lead from the petrol has spread from those roads. And these studies have been able to show that there's a very high relationship between the distance from roads and distance from industry and the amount of lead there, which suggests that obviously the lead is coming from the roads or the industries. So you can do tests for air pollution as well as soil pollution using AAS for lead. And one of the most important sorts of tests you can do with lead for AAS is you can do blood tests. And there's a place in South Australia called Port Pirie, and it's got the world's largest lead smelter. They produce 245,000 tons of lead per year. So you've got this huge lead smelter there. Obviously there's going to be some cases of lead entering the environment, and that can cause lead poisoning in people. So in that particular town, AAS blood samples of children are mandatory. And there's a bit of study here, but they've realised that there has been some damage done to people's intelligence and IQs and to their vitamin D metabolism because of the lead, and that infants and toddlers are at greater risk because they're more likely to put things in their mouths and increase the ability to absorb lead because their bodies are growing and because their brains are growing at that time. So lead can have a serious impact there. So this is a serious problem for the children living in Port Pirie. And because they've monitored this, and this is where you can talk about the impacts of AAS, because they've monitored the blood levels of lead in the children there, they've been able to detect some people have had issues with lead poisoning, and therefore they've actually put things into place to try and reduce the damage being done. And so because of this monitoring, the smelter operators had to put in lead pollution reduction strategies, and the government and the lead smelter operator have also improved housing and education programs. So AAS, because AAS had shown that yes, this lead smelter was causing a problem, that yes, these children had high blood levels and therefore their IQ was being damaged, that then forced people to take action and improve the issue. And this is just an example. This is just a map of the town where the smelter was. The smelter was located here, and these were the sites where they took samples of blood for people and figured out their lead concentration, and clearly there was a higher concentration of lead in people's blood living close to the factory or close to the smelter, and therefore the factories had to change the way they operate so they don't emit so much lead, but also sometimes rebuild houses around here that have had a lot of lead dust trapped inside them, but also educate people about lead safety as well. So by using AAS, there's been a positive improvement and reduction of lead pollution and increased safety to the people living in this area. Just a look at atmospheric lead. In Western Australia, prior to the introduction of unleaded petrol, motor vehicle emissions contributed approximately 90% of lead to the atmosphere, except for major point sources such as lead smelters. And in 1996-1997, the average maximum lead level was 0.22 micrograms per cubic metre. By 2001, 5 years later, that had decreased tenfold. So by actually monitoring the atmospheric lead using AAS, they can actually see that yes, introducing unleaded petrol had an impact on the amount of lead in the atmosphere. And by the 2001, the lead had got so small there was no point monitoring it anymore. And so this graph just shows you year by year the concentration of lead in the air. And it clearly shows that as unleaded petrol was being used and leaded petrol was phased out, the amount of lead in the air was reduced. So by looking at Port Pirie, we can see that AAS was very important to taking action to stop pollution, but in the Western Australia example, AAS was used to actually show the effect that the pollution reduction strategies had. They'd cut out leaded petrol, and they can show that did have a positive impact on the environment. So thus, AAS is vital in monitoring lead pollution, where it is, sources, uptake by the population, and effects of minimisation strategies. Are the strategies actually working? And with such information from AAS, new strategies to overcome lead poisoning and pollution can be designed and assessed. So it's a constant feedback. They try and improve the pollution, they can then monitor it, and then come back and decide, do they need new strategies or are the strategies working? So moving on to AAS and trace elements, or what is a trace element? So in analytical chemistry, so in chemistry terms, a trace element is an element in a sample that's got an average concentration of less than 100 parts per million, or less than 100 micrograms per gram. In biochemistry and biology, a trace element is a chemical element that's needed in minute quantities for the proper growth development of the organism. So we usually use in chemistry less than 100 parts per million is called a trace element. So something in that concentration or something needed in that concentration is a trace element. And that's clearly a very low concentration, 100 parts per million. And so it wasn't until the invention of AAS that we could really study the effects of these trace elements. And two examples in Australia are both agricultural examples that in coastal southwestern Australia, sheep health couldn't be maintained on similarly good pasture land. So even though this pasture land seemed very good, the sheep were just not healthy. And they did AAS analysis of the soil in this pasture land, and they found that there was cobalt deficiencies in the soil. Now, we might not think of cobalt as being a particularly useful element in our bodies, but cobalt's very important for vitamin B12 and blood cell formation. So you only need a very small amount of it in your body. It's a trace element, but it is needed. And therefore, by doing the AAS analysis, they could actually pick up it was this deficiency in this trace element that was causing the problem with the sheep. A similar problem was in arid parts of Victoria, couldn't support legume crops, and legume crops are things like peas, and they put nitrogen in the soil, so they're very important plants to grow, but they couldn't grow properly in this part of Victoria, and they did AAS analysis of the soil, and they eventually found that there was molybdenum deficiencies in the soil, and molybdenum is used by these legume crops to actually take nitrogen phosphate out of the soil and into the plants, and therefore, by knowing what problems there were able to do something about it. So by knowing what was deficient in the soils, so by doing the AAS analysis, they could figure out either the cobalt or molybdenum was deficient. You can then take steps to rectify the problem. They could use cobalt-enriched or molybdenum-enriched fertilizers, or change the crops, or change the livestock you grow on or you feed on these pastures. So knowing what the problem was, they did something to it. So they could do something about it. So a summary, in your notes, as we said before, you've got to write a summary. What are the problems caused by lead pollution? How does it get in the body? What are the sources of lead in the environment? How do you test for lead, i.e. AAS? In the body you can do blood samples, in the environment you can test soil or air filters. An example case study of each, so what's a case study where they've done environmental testing of lead, and what's a case study where they've done human testing of lead. Finally, what's a trace element? And some examples of AAS studies of trace elements. And why do they use AAS? So why do they need to use AAS to test those soils? Mainly because trace elements have impacts in such low concentrations that AAS was the only technique sensitive enough to measure those trace elements.